Good evening, everyone. As we're getting later into the afternoon, I feel we need to switch to good evening, and especially because this is our last presentation the of the day. So now I am having difficulties to see my screen. So how do I get to my next screen? I see the Facebook page and I don't see my screen. So I'm going to stop sharing my screen. Like I said, I was not going to do, but we're still going to welcome our last guest speaker of the day. But you have seen him already because it was on our first live session, Dr. Robbie Smith.
Hey, everybody.
Good evening. So we are finishing the day by talking about the Sargasso Sea. That's the topic of
Yeah.
the afternoon. Robbie's done a lot of research on it, so he's going to share some of his wisdom. And we're going to start by talking a little bit more about the physics of the Sargasso Sea. So I'm going to go back into my slides, and hopefully I'm going to be able to move on. So let's set up the stage of the physics of the ocean a little bit. And at least living in Bermuda, we all know about the Gulf Stream that is bringing us, warmer water. So we kind of like have a feel for the fact that the ocean is not static and the ocean is moving. But I'm going to like build on this because this is not the only current that does exist into the ocean. And if you look here, you will see that if there is a warm surface current at the top of the water column, there's also places where the ocean water cools down, it becomes more dense, and it sinks to the bottom. So it means that in some places of the ocean we have those like currents of like water masses that are moving at the bottom of the ocean, and also in mid-water as well. So it becomes quite complicated when you're looking at the overall circulation of the ocean. And there's a little note at the bottom there saying like, yeah, and it changes over time as well. So if you look at the history of the currents of the ocean, it can get a little tricky as well. So you might have heard or seen that word, thermohaline. I can't pronounce it. It's like thermo for temperature and haline for salinity. And it's the fact that there is a huge conveyor belt. You might have heard that word that connects all the waters in all the oceans. So it's not just currents in one part of the ocean, like in the North Atlantic or the Southern Pacific. We have a molecule of water that can travel from, being at the surface in the northern of the Atlantic to be down at the bottom of the ocean in the northern Atlantic, traveling south down all the way to the south of the Atlantic, and then go through the Indian Ocean to the Southern Ocean, and then go back up the Pacific, and then come back up at the surface. So it is very technical and tricky when you want to understand the whole physics and and the currents in the ocean. So here I am trying in 3 slides to summarize like a whole physical oceanography course. But I think it's important to understand currents because they're going to be very paramount in the ecology and the identity of the Sargasso Sea. But now, it's not just oceanography, it's not just currents, it's also winds. So you have to understand the winds that we have on the planet to be able to really understand how surface currents do work. So if you look here, we do have prominent winds that we call trade winds that you're going to see, going from it's like northeast trade winds between like 30 north and the equator. And then you have those westerlies that are between 30 and 60. So if you notice how they can kind of like link together at like moving that wind and like producing currents, you will see how the circulation of the atmosphere is also linked to the circulation at the surface of the ocean. And those red arrows here, which were my westerlies and my other trade winds, if I get them to go, you will see how underneath appear a circulation currents of the ocean that make water at the surface twirl and circle into what we've called gyres or gyres, something else I can't pronounce. And I think it's the perfect timing right now to pass it on to Robbie, because he's going to really zoom in and narrow in like with the on that gyre that we have around Bermuda, because it's very important for the definition of the Sargasso Sea. So take it away, Robbie.
Thanks, Alex. No, it's a great introduction to understanding what we experience here. We live in the surface waters of the Atlantic. It flows around us. And so it's really the combination of the wind plus the other underlying movement of water, like the Gulf Stream being pulled north, to set up a stage that helps us understand how all these things fit together. It wasn't until 1956 where a scientist at what was called the Biological Station, John Ryder, he was an oceanographer. He gathered information about what the water looked at in terms of different depths, in terms of temperature and salinity. That informed him about whether this was cold water coming from the Arctic or warm water going north in the Gulf Stream. And he began to synthesize, to bring together all this information that had been accumulating since World War II about what the oceans were doing. And he really got the big picture, is that they all work together. There's a reinforcing effect of water on the Gulf Stream moving north and west, and then the Canaries current moving from the north to the south, and then the equatorial drift, or driven by the northeast trade winds that push along on the southern latitudes. And they all conspire to create a very large mass of water that slowly turns. And what this means really in terms of things that are floating on the surface, could be a boat, could be a piece of fishing gear, it could be sargassum, is that they get controlled by these forces and they end up being held within this gyre. They can be pushed out, a hurricane comes along and ejects things out of it, but it generally works to trap materials that float on the surface within the gyre. And that explains the long history of success of the sargassum community. These plants and animals that are held together within this gyre system and allow for these long evolutionary developments of some really fascinating biology. So we're going to go to the next slide and start to think a bit more about this ecological system. We kind of know sargassum. It shows up from time to time on our coastline. We have a general picture that there are really two primary species here, Sargassum natans and Sargassum fluitans. But like any plants or any organism, not all identical. There's a lot of variation in what they look like. And so you can look at the bottom right-hand side, Sargassum natans, one long skinny leaves, and some of the Sargassum fluitans have kind of fatter leaves. And way over on the left, or maybe it's your right, I'm not quite sure what you're looking at here, is another type of Sargassum natans called Sargassum natans 8. So let's go to the next slide and I'll sort of tell you a bit more about that plant. It's kind of new. We hadn't really seen that plant, that form before, and it was kind of discovered because all of a sudden, and I mean like all of a sudden in 2011, going into 2013 and 2014, that particular plant became really, really super abundant in the Caribbean. And that's because it was sort of created outside of our gyre. It was created on the latitudes between Western Africa and northern part of South America. And the North-Sea trades would push that across the Atlantic and up into the Caribbean. And on the way, it began to feed on nutrients in the water, like all plants, nutrients in the water feed it. Some of those nutrients come from rivers in West Africa. They come from the rivers in South America. Some of the islands in the Caribbean have a lot of nutrient delivery. And this plant just exploded. This is a picture of my colleague Helen took on the coast of Barbados. We think we get sargassum. That doesn't compare to what they've been experiencing over the last 4 or 5 years, as one particular plant just exploded in abundance. And it's been a real ecological problem down in the Caribbean. So we haven't seen this plant a whole lot up in our latitude. It shows up from time to time. I found a piece about a week ago. I saw some in the fall, but it hasn't really became very peculiar. So that's kind of an interesting thing. When I started doing this project, we didn't know this was going to happen. Now this has occurred and I had to figure out, well, what does it mean to have this plant doing something that might be different than what the other plants are doing? So let's go on to the next slide. And really sort of tell you what I've been trying to do is try to understand more about the diversity of life that's associated with sargassum. We know a lot about this as a young biologist working at BIOS. There's a big project going on in the late 70s to study everything living in sargassum, and primarily to try to understand what a pollution problem was at that time of tar balls, and whether those tar balls were breaking down and being incorporated into animals that feed within the sargassum. So we get a lot of information about what was going on there. But then not much has been happening since that time. So there's really fascinating critters, and you might have seen some on the beach. If you pick up a piece of sargassum, you usually find that little crab there, Planes. It's sort of the last one that hangs on before it and rides that surf into the beach. Other animals are attached, and you probably don't notice them because you really need a microscope to really understand it. But the two really important communities, and the things that are attached can feed on things that are moving around, and things that are moving around can feed on things that are attached. Let's go on to the next slide.
And before I do that, I'm going to say that I really like that drawing. I really like, when you talk about like, life and like descriptions of species and things and drawing likes. And this is an amazing one.
Yeah, so I skipped over a point here, is that as much as all this life works within itself, it's also an awful lot of life that attracts animals in there. And we know that all juvenile sea turtles in the Atlantic spend time in the Sargassum community. At least that's an opportunity for them to be able to feed when they're just little baby turtles. And eventually they get bigger and they leave. And these are some of the things that they'd be looking for. These are some really fantastic pictures that a Bermudian photographer, Jessica Reeder, has shared with me of the Sargassum fish in the top left corner, swimming crab, and some of the shrimps that we find in there, and a little free-living snail called a nudibranch that's in there. There's a great diversity of life. So we know a fair bit about this, but the challenge is to figure out, is it still the same as it was back in the 70s? And there's other earlier data sets from the 30s that we have available to look at. So let's move on to the next slide.
These are truly stunning pictures.
I don't know how she does it. Here's some of the attached animals. There's sort of a lacy-like structure here on. It's a type of animal called a bryozoan. Just sort of grows. It's colonial, kind of like a coral, but not related. There are lots of barnacles. These are kind of small. They do get bigger. And down in the bottom corner is something called a hydroid, kind of related to corals. They have little tentacles and they capture things. And all these animals are actually doing that. They're actually harvesting plankton, which you can't really see, but we know it's there and it's really important. And by absorbing these plankton animals for their benefit and then excreting their waste, it actually provides nutrients that help support the growth of the plants, the Sargassum plants. So there's a lot of feedback in the system that really sustains it over time. Let's go on to the next slide, please. So the questions I've been trying to address and have come to really understand more about how similar these communities are around Bermuda and across the Sargasso Sea. It's a big question. There's big differences between the lower Sargasso Sea and our latitude, and it extends north of us for a ways. And also want to know, how are things different, or have they changed since the work was all done here in Bermuda back in the 70s? There's really not much work that's been going on since the since the early 80s. One study was done in 2011, 2012 by a group from the Monterey Bay Aquarium. And about that time, I got busy and I've been out trying to sample and collect material. We know Sargassum comes close to shore, and you really can't go just off Elbow Beach or off John Smith's Bay and pick up Sargassum floating there, because that Sargassum is then picked over by reef fish. As soon as that Sargassum floats in, fish just go into that Sargassum and they're looking for food. They're looking for shrimps and crabs. So you really have to get away from Bermuda. So where the effect of our island fishes is not going to have an impact on what you're trying to measure. So that forces me to go offshore. I'm going to the next slide. And this is how I got there. With the support of the Atlantic Conservation Partnership and the Bermuda Zoological Society, I was able to charter this research vessel. Well, it's a vessel that's used for a lot of research around the world, called the Sea Dragon. So we did a series of cruises in 2013, 14, 15, and 16, taking crews of Bermudians offshore for 1, 2, 3, 4, or 5 days. Tried to get 50, 100, 200 miles away and sample frequently enough to get some idea what the patterns are. So if I'm 10 miles away from Bermuda, is that the Sargassum look at all similar to the Sargassum that's 100 miles away? I haven't got that answer yet. Let's go on to the next slide. This shows some more of the cruise tracks we did in 2014 and 2015, just a little bit closer along the South Shore. It's a sailing boat, so we got to work with the winds. 2016, we went out for 2 days for 100 miles and didn't find any Sargassum, so we didn't luck out there. But we saw lots of great seabirds and measured some plastic pollution out there. So that's what we did, and this is who helped me. I had these great crews of Bermudians coming along from Bermuda College, some of our interns here, some graduate students from the U.S., Bermudian photographers, people who just participate and wanted to be able to go to sea for a few days to help do the collection and help me run the ship, because we have to do all the work, cook and clean and drive the ship, along with the captain, the 2 captains that were on board. So it was a great experience. I think everybody really enjoyed themselves. They got to learn something, and I got the benefit of their effort to help collect a large number of samples. Let's go on to the next slide. So what I've been trying to do is for every clump of Sargassum I'll pick up, I'll say, well, who lives in here? And I'll go through and I'll catalog all the different animals. And this is an example of one of them. This is one of the shrimps, the common shrimp Latrudes. And the graph sort of shows a comparison between all the data that was collected back in the 70s. So that's sort of on the left-hand side of the x-axis, is all the data from 246 samples collected at the BIOS back then. And it shows you how many were there per kilogram or per liter of sargassum. So you can see an awful lot of the counts of the number of the shrimp are pretty low, like 200, 100. And you come into what I've been collecting, there's about 90 samples right there, and there's more of them. And that's the thing that really struck me when I first started doing work. I was finding many more shrimps. Like my interns were just wonderful, would be counting and counting, like 100 shrimp, 200 shrimp. They were just really working hard to catalog how much was there. And that was the case for 2014, 15, 16. And then 16 was a bit of an interruption. We didn't have any sargassum here. I went to sea for 2 days, couldn't find any. And we began to see this transition to this other sargassum plant beginning to make its presence here. And my last set of samples are really sort of not showing that same pattern, but that's kind of normal in biology. You have periods where animals are successful, they reproduce a lot, and you get a lot of shrimp. And in other years, maybe not so much. And so other factors can control the success. But some of the very high levels and the numbers I see just seem to be very, very high there. Another example is another shrimp here called Hippolyte. And if you look at the 1970 samples, 246 of them, this shrimp only appeared in 9 of those samples. In the counts I've been getting here, I've looked at, in this case, only 85 of my samples. There are 58 of them. So the presence of this shrimp is completely different than its occurrence in the past. So we're getting about the same time scale. There's about 5 or 6 years of work back in the 70s. I'm about 7 or 8 years of work right now. So there's something different about that. Other trends I've seen here is that other types of animals like amphipods and other crustaceans are quite abundant. There's one single snail that glides around on the sargassum. It's also very abundant. And I'm not finding very many flatworms. Not a very interesting piece of marine biology, but they were very abundant in the past, and I can't find very many of them at all today. So that's kind of what I'm trying to figure out, is who's living there, how many of them, and are they similar or different to the patterns we saw back in the 70s? We know the oceans has changed a lot. It's warmer, it's slightly saltier, it's getting more acidic. We have changed who lives in and around sargassum. So let's have a look at the next picture. And we think about fishes, and you can find instances of lots of fishes associated with sargassum. They're there just like the turtles and seabirds looking for food. They also get some shelter. If you're a fish hiding under sargassum, you're somewhat protected from seabirds that might be looking to hunt on you. So in trying to characterize who lives with sargassum, my tool, which is a dip net or a surface tow net, isn't going to catch fish. You need a whole different strategy. So I really don't know whether the fish community has changed a lot in sargassum or not. You can certainly see some fish, and the picture right in the center here of all those plainhead fowlfish was taken by our great Bermudian filmmaker, J.P. Rouget. He supplied this picture for me. I've been out snorkeling a lot, and sometimes I only see a few fish. So I took these other pictures along with one of my grad students. So the changes I see in terms of the number of animals there, if you take away some of the predators, if the fishes are fewer, then you might expect to see more shrimp, squid, or crabs living in that sargassum. But I'm not sure yet. It's hard to put the whole picture together. So I'm just working on the one part, which is fairly simple. Now let's move on to another slide, and I'm going to change the story a little bit. As much as I am fascinated by the biology and the potential for things to be different in some ways, something else has been going on, which I'm sure you're very familiar with, and that's looking at the level of plastic pollution in the Sargasso Sea. Just as the sargassum is trapped by those oceanic surface currents, the same applies for the plastic. It's buoyant, it sits there, the wind and the tides will move it around, and the currents will move it around, and it aggregates here. So we've had a long series of investigations into the amount of plastic here by a group called the Sea Education Association. It's an undergraduate research program. They have 2 sailing vessels. The current one is at Colworth Kramer. They've been looking at what lives on the surface, including sargassum and all sorts of other critters in the surface waters, but also measuring the amount of plastic. And this graph shows you where the very red colors are, the density of plastic pieces per square kilometer. That's not a very big area. 100, 200,000 pieces of plastic per square kilometer. And they're not big plastic. They're kind of small. So this graph only goes up to 2008. They've been continuing with that. I've been on the ship, the Colworth Kramer, 3 times coming up from Puerto Rico with their students doing work on sargassum and also working on the plastic. So we're trying to add to that picture, how much is out there and is it changing over time? Let's go to the next slide, please. So one of the ways we can do that is, you can't spot the stuff. It's pretty small. We use this net called a Newston tow. We sort of drag it behind us on the ship. This is on the Sea Dragon here, and this is an example of a type of material we would catch there. This is, I towed this net for about 2 nautical miles, and there are 57 pieces of plastic in there. They're not particularly big. Some of them are only 1 or 2 millimeters in size, and that reflects the real character of the plastic in our ocean. It's pretty old. It's been trapped in this gyre for decades. You know, plastic that was washed in there from the land back in the late 50s, 60s, 70s, 80s hasn't really gone anywhere. It's just gotten smaller and smaller and smaller. Some is definitely sunk out, but a lot of it's just there in smaller and smaller pieces. And unfortunately, that makes it more and more vulnerable to more and more animals that, you know, make a living trying to feed on particles on the surface, or if the waves are and winds are strong, that some of these surface plastics will be washed below the surface and available to fishes there. So there's a lot of plastic out there. We know a lot more about other types of plastic because we've done a lot of beach surveys here from 2010 to 2016 with a lot of citizen scientists and youth groups. So we'd go to several beaches. We'd be very consistent in going to the beach right after a high tide. So the tide had come in, it deposited the plastic, the tide has gone down, the waves aren't disturbing that tide line. We go along for about 25 meters. We might do several of those transects along there, just picking up all the plastic that we can see down to about 1 millimeter in size. And without showing a lot of information on the next slide, give you some idea, what we discovered is that there's always plastic stranding on our beaches, and usually between 1 to 0.1 grams per meter of tide line, but up to 10 grams per meter of tide line. A few samples, 100 meters of plastic per tide line. So if you can just imagine all the plastic here on either of these panels, that's what we picked up along a 25 meter by 1 meter transect. That's a lot of pieces of plastic, and some of it's quite small. So this is just old material that's going to break down. And when it strands, it's worth us going out and picking it up. If it washes back in the ocean, it's going to sit there and break down. The last piece of work I just want to share is I've had quite a few students here, 2 Bermudians, Shane Antonician and Giles Lorimer Turner, and an Englishwoman, Justine Nathan, an American student, Ben Sacco. And we've been looking at—
Robbie. Shane is watching.
Sure.
Shane is watching.
Oh, that's very good. I'm glad to hear that. Hi, Shane. Appreciate all your effort. And we wanted to get a sense of who might be eating this plastic. And there's lots of fishes that make a living just opening their mouths, going through the water, taking out the plankton. And if there's a small piece of plastic, they're going to get that. So we looked at a number of these fishes. They're what we call our planktivores. So you can look down on the table, you can look for our common names: red-headed herring, reef silverside, Spanish sardine, hogmouth fry, and some of their predators. Because some of those predators will eat those fish, but they'll also eat particles in the water. They're visually oriented predators. They see something, let's eat it. And it might be good, maybe not. So we look at all these 14 species, and we find that across all these 257 fish we looked at, 42% of them had at least one piece of plastic in there. So it's definitely a transfer of the plastic into this fish's guts. Whether it stays in that fish's gut, well, it stayed there long enough for us to measure it, but some of the fishes didn't have anything, and that might reflect what they were feeding on that day. There wasn't any plastic water in the water. We didn't find any plastic in their guts. But what this represents is the potential to transfer what's associated with the plastic. A lot of this plastic sitting on the surface is absorbing chemicals, or was made with chemicals. And you take that plastic with those chemicals, they could be waste pesticides, waste herbicides, they're on the plastic, they get into that gut. The chemistry of the gut might cause some of those plastics to give up some of their chemicals, and it gets absorbed into the fish tissue. And that fish eats some more, and then eats some more, and then somebody eats that fish, and then we might eat that fish. So this is an opportunity for some of the chemicals to begin to concentrate in some of these fish tissues, and that's going to affect our food security. The potential for this plastic to become a vector, a way to move chemicals that are sitting in the ocean surface, stick on the plastic, get in the fish, absorb in the fish, and gradually be consumed by fish and move up the food chain. We don't have a lot of data on that chemistry. Very few people do. It's a possibility. Doesn't mean that a fish are going to become contaminated, but the more that plastic sticks around, the more likely it's going to become a risk factor for of the fishes that we have in here, and our ability to consume them without being concerned about any health effects. So this is a new area. We really come to understand how much plastic. Now we're learning where it's going, and some of it's going into our food supply. So that means we have to think about understanding what those risks are when we want to consume our seafood. So that's my happy story for World Oceans Day, that we have plastic in our ocean, and we have a lot of effort at a global level. And some of it came out of this next slide, looking at an activity we had here last year. This is the Ocean Plastic Summit. My assistant Shane was on board the ship, and this was an opportunity to bring together people from industry, from NGOs and science, to come out firsthand and jump in the Sargasso Sea and see that plastic and get an idea of the scale of this. If you live along North America, you don't see a whole lot of plastic stranding on your beach compared to what we were experiencing out here. So we had a perfect opportunity for these people to look at what was going on here, to begin to sit down and think, where are the solutions? And a lot of it's going to come from how industries that make plastic articles that we use that end up in our escaping from our waste system, get in the ocean and begin to break down and become a problem. Let's look at the next slide and give some idea of how many people were there. There's a lot of people, and a lot of people went away pretty inspired, and a lot of effort has continued. They've had another conference. They had a big event in London to highlight the showcase. They're trying to carry out another event this year, but the pandemic has really kind of they had to sort of cancel those plans. But we hope this has really generated a lot of opportunities for people who manufacture plastic products with packaging, that they can redesign them, and we as consumers can rethink what we do with them and begin to fine-tune waste systems so that we can more effectively capture this. Because most of the plastic, we understand, is not coming from fishing boats and cruise ships. It's coming off the land. It's people just being lazy and wasteful in how they manage their litter and their general waste systems are not efficient enough. So that's where the solutions have to come from. We can start with the products, start with changing consumer behavior. We have a chance to slow down the delivery of plastic into our oceans, both in the Sargasso Sea as well as everywhere else. So I'm not sure if there's any other slides. I can't remember what I had put in there, but
well, before we go that, like, spot the onions, right? So you have some arrows there. So I would like you to give a little shout out. So you mentioned that Shane was on the cruise. Anybody else on that cruise?
Shia, and I'm back there. Yeah, Shia Wellman, Nathan. There were other Bermudians who were on the ship before I got in. We sort of had a changeover of the Bermuda crew, but those are the ones I could spot in the picture right away. But it was a great opportunity for the students to really see how decision making can be accelerated when you bring people together and get them to sit down and think about things and bring up ideas and listen and think and innovate. And I think there will be some long-term benefits from this. There were some pretty substantial commitments from big industry to make.
It was amazing to have some of the younger generation as well. So, Micah and Ashia, they were like,
when
Ashia's a junior staff, and I think it's great to get that, like flame passed on.
It was an important opportunity when this cruise was being put together to say, let's look at who the constituents are. We have young consumers in Bermuda. They're looking ahead, what their world's like, and we can give them lots of sad stories, but about what the risks that are associated with climate change and the change in our ocean and plastic and fish guts. But here's a chance to sit down and see that people can drive solutions when they be able to be thoughtful, listen, and make commitments, and then find the steps to be able to carry that forward. So I think this was a really big turning point, and it's going to take another decade of work, I'm sure, but you have to start somewhere. And this was really a significant event to do that. And I'm glad that so many young Bermudians had a chance to see that from the front seat. That was really, really exciting.
And I think, Robbie, I don't know what you had after that, slide, but I think it's a great message to maybe finish, our live sessions of World Ocean Day on that message of there's a lot of work that has been done. But there's a lot of people working, still working, trying to understand, but the being positive, I think it's the being positive attitude that, let's not give up. And
lots of optimism. We can see when we stop doing things can get better. The pandemic forced a lot of reduction in our activity at a global level, and animals started showing up in cities and towns and places where they were excluded because humans were too busy in those places. Our atmosphere is cleaner. So making the changes is difficult, and it may cost money. It will take time, but nature's resilient and it can come back. Maybe not completely, but it'll be better than letting things go the way they are right now. So let's hope we can continue. No, that was my parting shot of
That was the last one, but I like the message about being positive and the next generation and the work that is being done and all that.
Well, I'd say thank you for inviting me to participate. I hope everybody found something of interest in what we did today. We had a lot of people in our circus, and it was thanks to you, Alex, for really hosting and organizing all this. And I enjoyed myself, and I hope it was informative.
It was a pleasure to have you. There a couple of other questions came as you were talking, and maybe I'm just going to ask one more. What about the huge quantities of sargassum we had, on our shores last year? Somebody was, one of our watchers was wondering why, how did it have an impact? Was it a good thing, a bad thing? So I'm just going to sneak that last question.
Yeah. So just as what Alex was saying about how winds work, winds force things together. So for sargassum, it gets aggregated. So when the winds sort of when the plants are growing, and they sort of grow a lot in the spring, and they grow as sort of vegetation, they can grow pretty, you know, if you don't mow your lawn, you see how much growth they can have. So when Sargasso is really growing, it can be spread out, but then it can be aggregated. And so when it gets aggregated, it's all in one place, and it sort of links together, forming big mats, or what we call long windrows. And it's just luck. It's just luck whether that aggregation just happens to be near Bermuda and lands on our shores, or it goes right past us. We have satellite imagery that we can sort of track that with, because what happened down south in the Caribbean really stimulated an awful lot of development of tools to be able to look out for things, to see what's over the horizon. So it's really, there's no predictability. I mean, oceanographers can sort of look at what the ocean is doing and look from space and say, okay, we can see some sargasso, and maybe it'll arrive here. And I've been looking at that as I've been thinking about when I want to go out and sample, what am I going to find out there? So there's no simple answer why why it occurred at a particular day or week. We haven't seen any here. We had some in December, and we had the whole winter without sargasso. It was in other places. It just wasn't here. So that's a fairly simplistic answer. It's kind of hard to predict.
No,
it's all controlled by what the winds and the currents are doing.
Thank you for that. So yeah, thank you everybody for tuning in today. That was awesome to hang out with all our presenters and with all our public. So that was great. We'll keep studying it. We'll keep fighting for it. We love the ocean. You guys know where to find us: the Bermuda Zoological Society, the Bermuda Aquarium, Museum, and Zoo. We are here for you. All right. Enjoy your evening. I think there's a wine tasting happening right now on our Facebook page by Sea Wine Changes.
We like Sea Change.
Time. And then there's a couple of songs by Nia Chambray later on tonight. So we are not quite done with our celebrations, but have a good evening.
Bye.